Hello students, once again welcome to Bholanath Academy. In this video students we are going to see chemical properties of carboxylic acid. Here we are going to see the third property students, that is reaction with phosphorus trichloride, phosphorus pentachloride and thionyl chloride. Here students please pay attention. Here we can also say phosphorus halide. These two are phosphorus and halogen, so we call as phosphorus halide. And here students you have sulfur and chlorine, so this is also called as sulfonyl chloride. Okay students, now you have carboxylic acid in your hand. Now we are going to react with these three reagent. What students, when they will react students, they will form acyl chloride. Only one product is formed, that is called as acyl chloride, which is very important product which we are going to use in drugs students. So students, how you are going to convert carboxylic acid, organic acid, into acyl chloride, which is very important product in industry students. So here students, carboxylic acids, all the carboxylic acids on heating with phosphorus trichloride, phosphorus pentachloride, thionyl chloride give the corresponding acyl chlorides. Okay students, so which type of carboxylic acid you are getting, you are taking same amount of acyl chloride you will get students. Okay students, in this reaction what happens students, hydroxyl group of carboxylic acid is replaced by chloride. Okay students, so what happening is in reaction students, so hydroxyl group is totally removed and it is replaced by chlorine. Okay students, so first reaction that we are going to see here students, suppose I am taking acetic acid students, carboxylic acid. First acid is what? Acid carbonyl having 2 valency, if one valency by methyl group, other valency by hydroxyl. This is the simplest carboxylic acid that we call as acetic acid. So students, you have acetic acid. What happens students when you add thionyl chloride, SOCl2, we call it thionyl chloride students. So when you heat students, when you heat it, these two reactant, what happens students, hydroxyl group, this hydroxyl group is replaced by chlorine. So students, carbonyl 2 valency, 1 valency will be always with methyl, and this hydroxyl of carboxylic acid is replaced by chlorine. This is called as acid chloride. Now what happens, you are getting byproduct as a HCl, H plus chlorine by HCl, and you are getting sulfur dioxide gas, which is removed. Sulfur is removed as a sulfur dioxide. So this is our product students, formation of acid chloride. So here we are getting acid chloride. This acid chloride is nothing but, because we have taken acetic acid, so we call as, this is also called as acetyl chloride. This is the action of, in examination sometimes they will ask action of thionyl chloride on acetic acid, so it will always gives you acetyl chloride, mind valuations. So if you are taking acetic acid, you will get acetyl chloride. That is why it is called as what? Corresponding acetyl chlorides you will get depending upon the carboxylic acid, which type of carboxylic acid you have taken. Second reaction students, action of phosphorus trichloride. Okay students, so you have carbonyl group, when one valency is always replaced by hydroxyl group, so we call as carboxylic group, and other I am taking with methyl, so this is nothing but acetic acid. When it is combined with phosphorus trichloride, when you heat students, what happens, this hydroxyl group of acetic acid combines with phosphorus trichloride, and what happens students, it is replaced, this hydroxyl group is replaced by chlorine of this phosphorus trichloride, and you will get, so here hydroxyl group is replaced by chlorine, and here this is methyl, so you are getting acetyl chloride. Along with acetyl chloride students, you are getting phosphoric acid, S3PO4. Okay students, since students here you have taken 3 molecules of chlorine, so you are getting acetyl chloride of 3 molecules. If you want to balance, you have to balance this acetic acid also. So here, because of this students, you have to balance, it is what, 3. So 3 molecule of acetic acid react with 1 molecule of phosphorus trichloride, and it will gives you 3 molecule of acetyl chloride and phosphoric acid. Very important students, in examination they may ask action of phosphorus trichloride on acetic acid, so you will get acetyl chloride. Now third students reaction that we are going to take students, you have carboxylic acid. What happens students when you add phosphorus pentachloride? Students, you have to heat it. Again students, you are getting acetyl chloride. So here this hydroxyl of acetic acid is replaced by chlorine, and this methyl will be as it is. And along this product students, you are getting PO tri and HCl. POCl3 and HCl, it is liberated. This way students you have got the acetyl chloride. So from acetic acid, action of phosphorus pentachloride on acetic acid, it will always give you acetyl chloride. So acetic acid you have converted into what? Acetyl chloride. Fourth reaction students, reaction with ammonia. Okay students, you have carboxylic acid students. What happens students when you add ammonia to this carboxylic acid, organic acid? If you are passing ammonia gas, what happens students? What happens to carboxylic acid? So carboxylic acid react with ammonia because ammonia is basic in nature and it is acid. Acid and base is always they are reacting to each other. So carboxylic acid react with ammonia to form ammonium carboxylate. First it will form ammonium carboxylate salt, which students on further heating at high temperature students decomposes to give acid amide. You are getting acid amide students. This is the formation of acid amide, which is very important product students. You for formation of protein, all that students, acid amide is the primary source. Okay students, to acid amide students, very important product. So carboxylic acid react with ammonia. First it will form ammonium carboxylate. This ammonium carboxylate salt, which on further strong heating with high temperature decompose to give acid amide, acetic acid. So this is students carbonyl. If one valence is always replaced by hydroxyl group, so it is belongs to acid group, and here I am replacing with methyl. So what happens students when you add, you are passing ammonia gas. This is ammonia students. This is acetic acid. Simplest acid I have taken, acetic acid. If you pass ammonia, what happens students? Form ammonium carboxylate salt. They will addition reaction will take place students. These two molecules will combine to each other, and this is reversible reaction students. So it will form. So this ammonia will be added to this carboxylic acid. So this one hydrogen, here it is what, 3 hydrogen, it will form 4 hydrogen. This is called as, this will be because of this nitrogen is containing 4 hydrogens, so this will be positive charge, and this will what, negative, oxygen will be negative charge. Okay students, that is why we call it is a salt. Okay, NaCl like salt it is forming. So but it is ammonia, so it is called as ammonium carboxylate. So name of salt will be ammonium. So you have to start the name from this side, and this is what, carboxylate. But which type of carboxylate students? Containing 2 carbon, so we call as acetate. Formation of ammonium acetate. What happens students when you heat it? This salt, if you on heating strong at high temperature, there is a removal of water molecules. Okay students, so there you will get, there is a removal of water molecule. Water molecule will vaporize from this salt. So what is remaining students? So this is carbonyl, this will be as it is. So if your water molecule will be eliminated from here students, it will form NH2. This is amide, but it is containing acid. It is from acetic acid students containing 2 carbons, so we call it acetamide. So this way students, we have converted acetic acid into acetamide. This is very important reaction students. Acid amide can also be prepared by acid amide can also be prepared by acid chloride with ammonia. If you have these two reactants, you can also prepare acid amide students. So first students, example I am taking here students, acid chloride example, very simple example students, that is acetyl chloride. This is the acid chloride, that is simplest acetyl chloride. What happens students? React with ammonia, NH3. Ammonia we are showing with NH3. This chlorine of acetyl chloride now react with one of the hydrogen of ammonia, and it will give you HCl. Now what is remaining here students? Only NH2. Now it will combines. So this way students, you have got acetamide, which is very important product students for the formation of protein. This way students, you can convert acetyl chloride into what? Acetamide. Fifth reaction students that we are going to see, that students of carboxylic acid, is reaction with dehydrating. D means removal of water molecules. So dehydrating agent is very important, that is phosphorus pentoxide. Reaction with dehydrating agent, that is phosphorus pentoxide, is very important students. What happens students when it will dehydrate the carboxylic acid? Now we are going to dehydrate carboxylic acid with the help of phosphorus pentoxide. So it will form acid containing not water molecule, that is called as acid anhydride. Okay students, now students, monocarboxylic acids. Monocarboxylic acid which is containing only one acidic group, that is it is containing one acidic group, is called as monocarboxylic acids. On heating with strong dehydrating agent, here students, phosphorus pentoxide is very important dehydrating agent. After that, if it is you don't have this phosphorus pentoxide, you can also use concentrated sulfuric acid. What happens students? It will form carboxylic acid into acid anhydride. This reaction is reversible. Okay students, anhydrides are readily hydrolyzed back to acid. If you have anhydride students, very reactive students, it hydrolyzes back to acid on reaction with water molecules. So that is why we are keeping anhydride in tightly bottle to avoid the contact with water molecules. So anhydrides are readily hydrolyzed back to acid on reaction with water. So students, in lab, students, it is very difficult to store anhydride. So anhydrides are readily hydrolyzed back to acid on reaction with water. So first students, we are going to see monocarboxylic acid. How monocarboxylic acid is converted into acid anhydride. Example, simplest monocarboxylic acid example students, carbon two valency students, one valency is always by hydroxyl group, other valency by I am replacing with methyl. It may be ethyl, it may be propyl. Okay students, so first carbon containing alkane, that is methyl, I have taken here students. It is called as acetic acid. This is the acetic acid students. Now second molecules also I am taking acetic acid. Okay, so now here hydroxyl group I have written in front of this. Now what happens when this acetic acid of one molecule combines with acetic acid of another molecule in presence of phosphorus pentoxide, P2O5. If you add P2O5 and just heat it, then only they will combine, and this reaction is always reversible reaction students. Okay students, this reaction is reversible, so you have to show the arrow this side also. So one arrow from this side and one arrow. What happens when this hydroxyl, one of the hydroxyl combines with one of the hydrogen of another hydroxyl, and it will give you water molecules. There is a removal of water molecules, and these two acetic acid will added by this oxygen bond like this. So this is the anhydride of carboxylic acid students. But yeah, the carboxylic acid that we have taken, that is acetic acid. Two molecules of acetic acid, on dehydrating we are getting acetic anhydride. This is acid anhydride, but which type of acid anhydride students? This is acetic anhydride. This is acetic anhydride. Acid anhydride is obtained by heating sodium carboxylate with acyl chloride. See students, acid anhydride is also we can get from sodium if you have sodium carboxylate and acyl chloride students. Again you can get acid anhydride, not only dehydration of carboxylic acid. If you have in your hand these two reactants, sodium carboxylate, acyl chloride, sodium carboxylate students, carbonyl 2 valency, and this along with oxygen you have sodium metal. Okay students, this is the salt. Sodium carboxylate is a salt. If you have sodium carboxylate, it is the salt. Okay students, here in general I am taking that is R, so it is a carboxylate. If you are replacing this R by methyl, so we call as sodium acetate. If you are replacing with ethyl group, we call as sodium ethanate. Okay students, now here students, sodium carboxylate react with acyl chloride. Acyl chloride that I have already explained students, that is nothing but CO. So these two are the reactant. Okay students, sodium carboxylate and acyl chloride. Now what happens students? Example students, simple example in board examination. So acid anhydride is also obtained by heating sodium carboxylate with acid chloride. Okay students, so sodium carboxylate, if you have simplest sodium acetate I am taking students. If one of the first alkyl group, that is methyl, if I will replace, this is called as sodium acetate. This will called as what? Sodium acetate. Okay students, so this is CS3CO. This is sodium acetate. Okay students, we call as what? Sodium acetate. Sodium, and this is acetate. Now combines with, instead of this alkyl I am taking methyl, so it is called as, okay students, this chlorine I am writing this side students, and methyl I am writing here. Okay students, so this is called as acetyl chloride. Okay students, what happens students when you heat it? Again students, there is a formation of salt. Here this Na plus now combines with chlorine and it will gives you salt. When this salt will eliminated this bond, there is a formation of bond between oxygen and this carbon. So students, this oxygen I am writing here. Now this carbonyl will be like this, and here students, this carbonyl will be like this. So there is a formation of acetic anhydride. They may ask the reaction, so only this reaction if you write, you will get the full marks. That is how the acetic anhydride is formed. Sixth reaction that we are going to see, that is reaction with soda lime. You have carboxylic acid in your hand. Now what happens students when it will react with soda lime? So that is nothing but students, it is also called as decarboxylation of carboxylic acid. There is a one carbon will be eliminated from the carboxylic acid if you add soda lime. So that is why it is also called as decarboxylation of carboxylic acid. One carbon will be always less than the carboxylic acid. Okay students, so reaction with, if carboxylic acid is containing 3 carbon, so 1 carbon will be eliminated, minus 1 carbon. So that is why it is called as decarboxylation of carboxylic acid. Sodium salt of carboxylic acid on heating with soda lime gives hydrocarbons. So students, you are preparing hydrocarbons, which is very important as a fuel. Understand students? So you can convert acid into fuel. How important this reaction is, students? So reaction with soda lime is very important reaction. Soda lime gives hydrocarbons, and when you add into carboxylic acid, which contain one carbon less than the carboxylic acid. You have started the carboxylic acid from 3 carbon, so you will get the hydrocarbons containing 2 carbon. Okay students, so but you are getting hydrocarbons, and mind well. Now sodium salt of carboxylic acid on heating with soda lime gives hydrocarbons which contain 1 carbon less than the carboxylic acid. If it is 3 carbon, so you will hydrocarbons will get 2 carbon, but it is hydrocarbons. Simplest example students I am taking, that is sodium salt of carboxylic acid. Okay students, so here we are going to take directly the salt of carboxylic acid. Okay students, so students, carbonyl is having 2 valency. One valency will be always with, I am replacing simplest example of carboxylic acid, that is so acetate I am taking. Okay students, 2 carbon. So here students, but we are talking about sodium salt, so here the oxygen will be positive, negative charge, sorry students, and sodium will be positive charge. Understanding, this is the salt, this is the nature of the salt, but which type of organic salt I am taking, students? Sodium, and here it is containing 2 carbon, so name will be sodium acetate. Sodium acetate. So sodium acetate salt, students, on heating with soda lime. Soda lime is nothing but, students, mostly it is a mixture of NaOH and calcium hydroxide. Okay students, NaOH in presence of calcium hydroxide, calcium oxide, students. This is calcium oxide. If you heat, students, what happens? There is a formation of this sodium. This sodium will become 2 sodium. We are getting Na2, and here, students, this carbon containing 3 oxygen. This oxygen, this oxygen, and this oxygen will give us a sodium carbonate. It will form the carbonate. This is very important, students. This carbon is eliminated. Now one of the hydrogen. This hydrogen now combines with this, and it will gives you methane. This is a formation of methane. Okay students, this is the hydrocarbon. Okay students, so you are getting methane. If you have started there from acetate, so one of the carbon will be eliminated as a carbonate. So this is very important, students. This way we have got the hydrocarbon, that is methane. So if you are taking sodium acetate containing 2 carbon, so you are getting 1 carbon hydrocarbon, that is methane. If you start propane instead of acetate, so if it is 3 carbon, so you are getting hydrocarbons containing 2. Okay students, this is the very important reaction, students. Last reaction that we are going to see, the reaction with reducing agent. Very important reducing agent is lithium aluminum hydride. Why it is a reducing agent? Because it is containing hydrogen, 4 hydrogen. So this is the lithium aluminum hydride. Reaction with reducing agent lithium aluminum hydride. Reduction, you have carboxylic acid. What happens, students, when it is reduced? Carboxylic acid is reduced. So carboxylic acid on reduction, students, form primary alcohols. For that, students, you have to use the powerful reducing agent like lithium aluminum hydride. This is lithium aluminum hydride. Also you can reduce with diborane also. Diborane is also containing hydrogen from aluminum hydride. Okay students, so simplest, students, this is the carbonyl. One valency is always by hydroxyl group, another by methyl. So simplest acid I am taking, that is called as acetic acid. In IBC system we call as ethanoic because containing 2 carbon. So we call as which type of oic acid? Ethanoic acid. Ethanoic acid is nothing but acetic acid. Now on reduction with lithium aluminum hydride in solvent ether, the reaction is totally in solvent ether, then you have to add the acidic water. So what happens, students? So this methyl group will be the as it is, but this carbonyl, this oxygen, this is accepting hydrogen. This carbonyl now is converted into methylene, and there is a hydroxyl group. Okay students, so this is called as ethanol. Very important, students, this oxygen will be eliminated as a water molecule, and because it is producing so many nascent hydrogen, so 2 hydrogen will go and it will combine with CH2. Okay students, so here I think 4 hydrogen, it will give lithium aluminum containing 4 hydrogen. So 2 hydrogen will be as a water, and 2 hydrogen will combines with this acetic acid and gives you ethanol. So this is the nothing but primary alcohol because this OH is attached to primary carbon. So this way, students, we have got the primary alcohols from acetic acid. This is very important, students. This way, students, you have to go through the reaction and board examinations. Same types of questions they may ask. This is very important. If you like my video, please share it, subscribe it. Thank you very much. Have a nice day. God bless you.